Hi guys, today we're going to talk about energy. Now we're going to go ahead and skip chapter 9. Chapter 9 is going to talk about some sorts of energy or some forms of energy, but it also talks a lot about simple machines. And so we're going to go ahead and skip that section and we're going to move on to chapter 11. Alright, things we want to pick up on that we might have missed. Some simple equations you should have seen as a freshman. So here they are. Alright, we want to remember work. Alright, work is a force that is applied through a distance. So if we put a force on something and we actually move it, we're actually doing work. Pretty important. We're going to see it quite a bit. Now, let's break this down really quick. The equation, or not the equation, the unit for force is a Newton, and our distance is going to be meter. So that's a Newton meter. A Newton meter is another name for a joule. Okay, so this is measured in Newton meters, which is also known as a joule. Now, joule is going to be our energy unit. Every time we see joule, something energy is going on. So when I see joule, I can interchange my work equation into kinetic energy, or more specifically, the change in kinetic energy. If I have some kinetic energy and I'm seeing that change, that's the amount of work that is being done. So we need to go back to that freshman year and we need to remember what the kinetic equation is, what the kinetic energy equation is. And that is K equals 1/2 mass times velocity squared. So this is also a Newton meter or a joule. Now we can break all that down. When we square those, we end up with meters per second squared. So meter, second, seconds. They cancel out with our mass and we're left with this. Okay. So joules coming in handy. If I want to know my work done, all I need to know really is my kinetic energy. It's going to be pretty handy. Alright. Things we're going to see with kinetic energy. If I have kinetic energy, and that's the amount of work that I actually am doing, or the amount of, if I have a motion, if I have an object moving, we're performing kinetic energy. I'm beyond the potential to have energy. I'm actually doing it. We team that up with potential energy, which we write as the big old U. Remember, we already used P. P went with momentum. But our next equation is going to be that potential energy, U equals mass times gravity times height. Also in Newton meters or joules. Now, if I take these guys together, kinetic energy plus the potential to do something, I end up with what's called mechanical energy. We just refer to it as E. Okay. Now I actually can do something. This is how, say, a turbine works in a dam. Okay, water's falling. You have the potential. As it's falling, it's being transferred. And what it actually does is it actually moves something, that mechanical energy. Okay, also Newton meters and joules. All right. We have one more equation we want to cover, one more thing beyond these simple equations, and that is power. Okay, that's our other big P. I guess we have a big P, which is power, little p is momentum. Power equals the rate at which we do work. Okay, if we can do work faster, that's just we're more powerful. Okay, so things that do work fast, quickly, are powerful. Things that take a long time to get it done may end up doing the same amount of work, they're just not as powerful. So if Gardner's in the weight room, and Gardner throws those 5-pound dumbbells up, like it's nothing. He does a whole bunch of them. He might, at the end of the day, move as much weight as, say, one Mr. Nick Broyles. But Nick can do it all in one motion. Okay. So, with power, we have work over time, which we have work, which is a joule. Time is a second. So we go with our unit there of a joule per second. Okay, we're going to go over more concepts next week when you're actually back. Guys, I hope you have a great Thanksgiving or have had a great Thanksgiving. We'll see you next week.